Okay, wants us to use a Fisher projection to represent this particular stereo center, or each stereo center in the molecule. And so you might have the initial inclination to say, okay, I've got three stereo centers. Let me draw 1, 2, 3 different possibilities. And then for this first one, you would say, okay, it's connected to an H, a CH3, and a CH3. Well, what does that mean in this case? If this carbon is connected to two CH3s, then it's really not a stereo center. Okay, and so what do we need to do? What we need to do is we need to actually just draw two stereo centers. And so we're going to think about this one. Let me change colors, this one and this one. And so I've got there and there. So what is it connected to above here? It's actually connected to an isopropyl group. So I can go ahead and write that down. So there I've represented that top group. And so now here comes the big deal about Fisher projections. If a Fisher projection means that vertical bonds are coming towards you and horizontal bonds come towards you and vertical bonds move away from you, what that means is that's actually an artificial projection, because typically the lowest energy conformation would be where the structure zigzags. And so that means that if I were to look straight down on the molecule, this bond would be going towards the looker, but this bond would be going away from the whoever was looking. And so this isn't actually a correct representation of a Fisher projection. So the goal is, what you really have to do is you have to be able to translate the stereochemistry correctly. And so if you look at this one is correct in that the bonds are both going away from you. And that's what we mean with when we talk about a Fisher projection. Horizontal comes towards you, vertical goes away from you. And so if I'm looking straight down the molecule, then these two bonds are in fact going away. And so I can get my ethyl group, which is here, and I can draw that out there. And I can directly orient the methyl group in the direction that I see it. It's moving away from me. And so now what I'm doing is I'm looking, instead of looking at it from the side, I'm looking at it from the top. And so that would imply that the methyl group is here. And so that means this is there. Now, what I have to do in order to orient this one correctly is I have to rotate this entire group so that the bonds point the other direction. And what that means is that the OH switches to the other side. And so what I want to do is I want to make sure that I've done that correctly. And in order to make sure that I've done that correctly, I need to actually specify the stereochemistry. Because as long as you've specified the stereochemistry correctly, then you're fine. And so let's take a look at what's going on with these two stereo centers. Okay, with this stereo center, the one that has the OH, the stereochemistry should be, here's group number 1. The hydrogen that's coming towards me is group number 4. And then it looks like this would be group number 3, and this would be group number 4. And it's this carbon that breaks the tie between 3 and 4. If you're still having some problems seeing that tiebreaker, then I suggest that you kind of go back and do a little bit more practice with stereochemistry. Okay, and so let me back this up. It's not 4, it's actually 2. So I've got 1, 2, 3. That's a counterclockwise direction, but my lowest priority group is going away from me. So it's actually, so instead of S, I should say it's R. So is this actually an R configuration? Did I do this right? I think I did, but let's just double check and see. Well, we've already done the configuration. This is 1, 3. This is 4. And then that one is 2. And so what do I get? I get 1, 2, 3. That's counterclockwise, right? That's counterclockwise. So we would say that's an S configuration. But what does the Fisher projection mean? It means that this bond is coming towards me. So the S configuration would have to be reversed. And so I did show it in the R stereo configuration. All right, what about this other one? What about this guy here? So I've got the hydrogen group coming towards me. That's going to be priority number 4. What are the other priorities? The methyl group is going to be priority number 3. This guy and this guy are tied, but this guy is going to win because it's connected to an oxygen. This guy is going to not win because it's connected to only another carbon. So it's 1, 2, 3. So I got 1, 2, 3 like this. This is also a counterclockwise rotation, but that 4 priority coming towards me means I need to switch it to R. So this one should be R. So let's see if I did that correctly. So here's my 4 priority group. Here's my 1 priority group. Here's my 3 priority group. Here's my 2 priority group. So it's 1, 2, 3. That's counterclockwise, but again, the hydrogen is coming towards me. So I would reverse my counterclockwise designation from S to R. I got that right as well. So I've correctly represented the molecule on a Fisher projection. Okay.